Today's lesson is about u substitution. Before we go on and I show you u substitution, we need to remember something from derivatives. So if I tell you that f of x is this function, 1 plus x squared cubed, if I ask you to find the derivative, what rule do I have to apply to this to find the derivative? The chain rule. That's because there is a function inside of another function, right? Okay, so let's take that derivative.
3,
Yep.
1 plus x squared, all squared, and then plus times 2.
Okay, great. So wouldn't that really turn into 6x times 1 plus x squared squared? Yeah. Okay, so there was an inside function and an outside function. So here's my first example that I'm going to ask you today to take the antiderivative of. Let's take the antiderivative of 6x times 1 plus x squared dx, the thing we just got as our derivative, right? So don't we already know what the answer is going to be?
It's not that.
Thank you. So our answer is going to be whatever f of x was in the review problem that we just did. But we got to see how. So it's not called a chain rule for integration. It's called a u substitution. So what you're trying to do is figure out a function that was kind of inside of another function. Okay, so if we look at this, how about if I were to let u, what looks like it would be the most inside function? That's a good place to start. It's not always going to give you the correct u, but it's a good place to start. Okay, so if u is 1 plus x squared, what I'm going to do is I'm going to change these x values over to u values. So instead of it being a dx here, it would be a du. So we have to figure out what is du. What is the derivative of u? We're really doing this with respect to x. What is du with respect to x over here?
2x.
It would be 2x. Didn't we take the derivative with respect to x? So that would really be 2x dx. Okay? So if we look over here at this problem, could I rewrite it so that I had a 2x dx in here? Could I rewrite it this way? 3, 1 plus x squared squared, and then 2x dx. Could you separate it and pull it apart that way?
Yes.
Now what we want to do is I can do a u substitution into this problem. The 3 stays here. What am I going to change this 1 plus x squared to be? U. So then this is u squared. And then what does all of this turn out to be?
Just u prime.
Just u prime. We just use du here instead of u prime. So we do use du there, so it matches our integration notation. Now, isn't this a very simple problem to integrate?
When we did this.
Can you integrate this?
Yes.
Yeah. It would be u to the third, and we'd have this 3 divided by that new exponent of 3.
So your
So my antiderivative is just u cubed
plus u.
plus c. We have a constant.
Oh, is that du? Is that a constant value?
No, this du is telling us we're integrating with respect to u. Like this was telling us to integrate with respect to x. But we did have to substitute. The value of du comes from 2x dx. So this is just du. So it's just a substitution there that gets rid of this 2 and this x for us, so that we're not mixing up x's and u's together. So we have to find a way to remove all of the x's and change them over to either u's or du's.
So you just kind of like phase it out.
Well, yeah, I substitute it out. That's why it's called u substitution. This value right here is du. See?
So when you said u, like the innermost function became u, So that's, okay, I get it now, because you were taking the derivative of the original, and instead of doing like the chain rule on the top, you just used the derivative of u.
Mhm.
Okay.
Mhm.
I guess it is the same thing.
Do I want my answer to be in terms of u? What was the original problem in terms of? X's. So we just now need to go back and substitute u is the same thing as 1 plus x squared. So really our answer to this question is 1 plus x squared cubed plus c. We'll try another problem in it, maybe it'll make more sense after you've seen another one maybe.
This is weird because I feel like the du should still have value since it's technically 2x.
The du does have value, but when you integrate with the du, now it's going from having value here to making it the right notation to be able to take the integral with respect to u.
So you keep it.
All these problems that you did last night on page 356 had that dx at the end. Remember, you already have this notation, integrate with respect to x. It's got to have the d something at the end, and we need for these variables to agree.
But what's the value of it? Like,
It's telling you what variable to integrate with respect to. Just like when we see a derivative, remember when I say dy dx, that's telling you take the derivative of y with respect to x. Derivative of a function y in terms of x. This du here is telling us to take the antiderivative with respect to u. These variables must agree. Does that dx trip you up?
No,
What does that dx tell you?
Just that it's in terms of x.
It's in terms of x. So I have changed this entire integrand over into being in terms of u. You can't just throw a du in there. You have to actually calculate what du would be. The derivative of u would be 2x dx. So then you have to hopefully pull that out of this integrand so you can really substitute in what du is. Let's try another example.
So you take the derivative of the original to find the innermost function, set that equal to u, and then find the derivative of that, and that's like du.
Well, you're not going to know this ahead of time. I did this to review with you chain rule,
Oh.
so that you could see when we got done here that this really was
Okay.
the antiderivative.
Do I-
But you're not going to have that information ahead of time
I've
from
been
here on
looking-
out.
I've been looking up there trying to relate it back. I'm like,
That
why
was
did you
just
do that?
review about
Okay.
chain rule so that you could see that this really is the antiderivative of that. Let's try this next example and see if it makes any better sense.
So there is a chain rule in integrating?
No, there's not. There's this thing called U substitution, which allows you to take out a complicated function and put in a simpler function in its place. So this is related to the chain rule, but there is not a chain rule for integration. We're doing the opposite thing.
Wouldn't it be easier just to multiply it all out and then take the integral of that?
Could you have multiplied this all out, then distributed and taken the integral? Yes. Can you do that here?
Or no.
No, because this is a square root. So your method would have been fine for this example. It's not going to work for every example. This one you can't FOIL out and distribute because this is a root, not a power, an integer power. I mean, you can't multiply this out because this is a square root, right?
So
Okay.
u in this situation is 3x minus 5.
We don't really know until we get into the problem and try it. That's a great place to start. So yes, I'm going to start. I'm not going to say that's what u is until I work through here and make sure I can do some kind of substitution here. So we're going to try letting u be 3x minus 5. That's your insidemost function. Then what would du really be? 3
Oh, yeah.
dx, correct. So that's 3 dx. Does this integrand contain a 3 dx?
Yeah.
Yes, it does. So what I'd like to do is rewrite it this way. Couldn't I pull that 1/2 out? And then I would have 3x minus 5 to the negative 1/2. And then times 3 dx. You see how I just expanded that integrand. I haven't changed anything yet. I just rearranged it so that I would have this value, so that I can substitute in the place of that du.
Okay, I think that.
Okay? So this can now be rewritten as the integral of 1/2 u to the negative 1/2 du. Isn't this a much simpler integrand? We should know how to integrate this. This one we don't, because it's got a function inside of a function. But this one is something we can integrate just using our exponent rules. So you're going to add the 1 to your exponent. So that becomes u to the 1/2 divided by 1/2. When I've already got this 1/2 here.
Yeah, so it just
Becomes
becomes
1.
So that just becomes u to the 1/2
which is actually
plus c. But don't leave your answer in terms of u.
3x.
This would be 3x minus 5. You could put it under the radical if you wanted to. Or you could leave it with a fractional exponent of 1/2.
I have a question.
Yes, sir.
Why not just why not even not even use a radical symbol when you're teaching? And just teach it as a fraction.
So just because, like, that's how
Because
it
if,
is on tests.
well, for one thing, if I ask you to evaluate 16 to the 1/4, you've got to know that that means it's the 4th root of 16.
So why not teach that instead of using the 4? Like, why not just like not even use a radical and just use that?
Because this, I don't know how else to explain what 16 to the 1/4 is without saying take the 4th root of 16. Do you see what I'm saying? I mean, how are you going to calculate 16 to the 1/4 if you don't know about roots?
With the calculator.
How are you going to do that without a calculator? I said, how are you going to calculate?
Calculators are
We're not going there.
already created,
Thanks.
so you.
Need you to write down the number on a note card and your name. And then, yes, you can take that home.